long run, we'll do this as follows. Alright, we'll have decided that it's a one-tail test. And then the question will become which tail. What we really want is that the sample value and the particular tail are both on the same side of the distribution. So in this particular case, we have the sample value is above the mean, so we want an upper tail test. If the sample value was below the mean, we'd do a lower tail test. So when we ask ourselves which tail, we can do this mechanically and say, well, our sample value, this problem was 83.4, which is greater than the middle of the distribution at 75. Alright, from this we can get two things. First, that it's, as we've already discovered, an upper tail test. And secondly, which at first is a little bit counterintuitive, that the alternate, not the null, is that mu is greater than 75. Alright, so what we have is so far that x bar is greater than $75, so we know the sample value is greater than 75. What we want to know is the true value for the population greater than 75. So we put that in the alternate, and that starts us off on our hypotheses. Alright, so let's start from there, write down both hypotheses, but now we'll include interpretations. Alright, so the alternate is mu greater than 75, and the null is the complement, mu less than or equal to 75. Alright, so the alternate, the interpretation we can put down is that the average balance is greater than 75. And the null is everything but that. Average balance is not greater than 75. Some might find this a strange way of saying this, and you might think, why not say it's less than 75? Well, it's less than $75 or it's equal to $75, so a neat way of saying it is not greater than 75. Alright, at this point we would draw a diagram so we can get our calculations on the way. But this is again a sampling distribution of sample averages. The middle of that distribution, 75. We decided that this is an upper tail test. We'll put the entire alpha, 5%, given to us in the problem, in that upper tail. So we're going to calculate this limit, and to do that, just like the two-tail tests, we need the standard deviation. Alright, so that's standard deviation. It's S divided by the square root of n. Alright, S 23.65 n 100. So 23.65 divided by the square root of 100. Square root of 100 is 10, so the standard deviation of the particular sampling distribution is estimated to be 2.365. Alright, so we're going to calculate now the upper limit. Alright, it'll be mu plus since we're going up from the mean, so the mean plus a certain value to get us up here. Alright, plus in general z with subscript alpha times s of x bar. So far we have our s of x bar, we don't have our z value in this case. Our z values is z with 5% of the tail, and we need to go into our tables to find that value. Alright, so here we are. Our t-tables, we use the last row for our z values, and we want 5% in one tail, so that value is the 1.645. Alright, so now we're ready to calculate our upper limit. Upper limit being the middle of the distribution, 75 plus 1.645 times the standard deviation of the sampling distribution, at least the estimate thereof, 2.365. And that works out to be 78.89, again to 4 significant places. So this upper limit up here, alright, is 78.89. So drawing a diagram so we can do the decision rule. We have the middle of the distribution, 75. We calculate the upper limit to give us 5% in the upper tail. That was 78.89. So if the null is true, remember the null, you have it already somewhere. The null was mu less than or equal to 75. So if the true average is at most $75, we'll find sample values encroach all the way up to about 78.89. But beyond that, it's unlikely that we'll have sample averages and have the true average be $75 or less. Alright, so that's how we do our decision rule. So, first part for the acceptance region. If x bar is less than or equal to 78.89, alright, null is possible, therefore do not reject the null. If the interpretation is possible, null is correct, or it's possible that, and go back and check the words that we put behind the null. It's possible that the average balance is not greater than $75. Alternatively, if x bar is greater than the upper limit of the acceptance region, out where we do not expect to find sample averages if the null is correct, we get beyond there, we'll reject the null. Otherwise the sample value is too high, and in its place we'll accept the alternate. And for the interpretation, it is likely the average balance on these credit cards is greater than $75. Alright, so now we're ready to do our decision. Alright, so let's get our sample average. Sample average is 83.4. Alright, 83.4 is some value up here in the upper tail. So we go with part 2 of the decision rule to reject the null. So decision, since x bar is 83.4 in this situation, which is greater than the 78.89. Alright, we're in the realm of, beyond the realm of normal sampling error, so we'll reject the null. Null is unlikely. And in its place accept the alternate, and say the alternate is likely. Alright, and finishing this off, the interpretation, it is likely the average balance is greater than $75. And that's the end of that particular one-tailed test.